Hello, in previous section we have learned how to find the distribution of one function of two random variables. In these sections, in several videos, we will learn how to find the joint distribution of two functions of two random variables. In fact, finding the joint distribution of two functions of two random variables is much easier than finding the distribution of one function of two random variables, and we'll see why. So if you have a pair of random variables x and y, so giving these two to a function, let's say g, give us a new random variable, let's say z, and then we give these two random variables to another function h, gives us a random variable w. So in summary, we could summarize these two in a block diagram like that: x and y in a function which has two inputs and two outputs, z and w. So one function for z, one function for w. So we are interested in finding the joint behavior of these two random variables in terms of the joint behavior of the two inputs. So in this particular video, we studied the joint behavior of two functions of two random variables. So assuming that we have two random variables, a pair of random variables, and we assume that we know some behavior about joint distribution of this guy. For instance, we could know the joint PDF or the joint CDF, and assume that we have two specific functions of g of x and y. Using these functions and random variable, we can form a new bivariate denoted by ZW. So basically here you have two inputs, x, y, and then this function here gives you a new pair of z and w. And we want to know what is the joint behavior of the output when we know the joint behavior of the input. So we shall express some statistics of z and w in terms of the joint statistics of x and y, and the functions, the two functions of g and h. So this is easy. If you want to determine the joint PDF of z and w, so basically this joint CDF means probability that this z is smaller than equal than this real value z, and this random variable w is smaller than or equal to this one. So this is basic definition of the joint CDF of z and w of z and w. Obviously, the concept in this video will be easily generalized to multiple inputs, multiple outputs of multiple random variables. So this event means that the random pair x and y, because if you look at these events, it means that you have, let's say, z, and then you have w. So the real value z is somewhere here, and the real value w is here. So you want to find a probability that the random pair of z and w to be inside this area, this shaded area. Obviously, these points are transformed from xy coordinates. So if you have, this is x and this is y, each point here is mapped to some other points here. This point may be mapped here. So we are looking to find the inverse of these y in xy. So let's say these set of points inside this area are the points that are mapped in this shaded area. So we need to find the probability of this one. So this is why we define DZW, the set of points. So DZW is the set of points in XY plane which are mapped to this shaded area, to the, so let's say I put here blue area. So this is Z, this is Y, and the area here into the blue area. So basically we need to find these, to solve this inequality and find the region. So clearly the event that the random pair xy is in dz, so this is a region in xy plane, and this is in zw plane. So this is the same event, this is the same set of outcomes, because you have a sample space and then this C generates a pair of x of C and y of C, but this pair is then transformed through your input to the system with two inputs, two outputs, into Z of C and W of C. So basically this is as a set of points, is a subset of points in your sample space, okay? So therefore the probability, this joint CDF, which is this guy, is probability that Z is smaller than or equal Z and W is smaller than or equal W. So this guy is probability of this event, and because this event is equal to this, so you need to do a double integral over this area. So remember that this DZW is an area in XY plane, is a subset of 2D plane in XY. So basically finding the joint CDF of f of Z and W has two steps. First, drawing this region, and the next step is to do the integral over this region. So this is one step, calculating this integral, and the first step is to determine this one. So this region determines the boundaries of this integral. So this set determines the boundaries of this integral. So we'll have some examples. We will determine the boundaries and then we do the integration.